Hi, ladies and gentlemen. Today we are going to do a review over factoring, a review over the factoring that we know, and I'm actually going to introduce a few more factoring tidbits for your mathematical entertainment. So, this one, grab this note sheet, factoring practice. So, the first rule of factoring, always, 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 and forever, is that you factor out a GCF, which is our greatest common factor if possible. Now, that can be a number or it can be a letter, but it's anything that all the terms have in common and can be divided by. So, that's the first thing you're going to do is look for a GCF. Then secondly, you have to determine the factoring technique that you need to use. The factoring technique that you're going to use is always going to be based on the number of terms you have. So remember, terms, we learned in 5.1a, terms are separated by an addition or subtraction sign. So we'll count the number of terms, and then that'll tell us which chunk of these notes to look at. So this part we haven't looked at for terms yet, but actually I want to skip that. So when we do four terms, we're going to factor by grouping. But that's something new. So I want to skip that for just a second, and we're going to go down here and remind you how to factor with three terms. So when you have three terms, you will factor using the AC method. The AC method. So you will have some problem that'll look something like this. 30x squared plus 65. Actually, let's make this to the third. 30x to the third, 65x squared minus 140x. Okay, so this has three terms. 30x to the third is the first term, 65x squared is the second term, and negative 140x is the first term. So always and forever, the first step of factoring is to look for that GCF. Now remember, GCFs can be numbers or letters or a combination of both. So if I look at these, I notice that 30, 65, and 140 can all be divided by 5. And it looks like they all have an x. So I can take out a 5x from all of these. And to take that out, I will be dividing. So 30 divided by 5 is 6. I have x to the third. When I divide, you subtract 1. So this will now be x squared. 65 divided by 5 is 13. And again, I subtract. And then negative 140 divided by 5 is negative 28. And we subtract the x, so there will not be any x's with that one. Now to do the AC method, we are going to take our A term and multiply it by our C term. So 6x squared times negative 28. So 6 times negative 28 is negative 168x squared. So now we are going to start making our list. So you can grab a calculator or use your head and just start dividing. So 168, I know I'm going to have 1x and 168x. If I divide by 2, I'm going to get 2x and 84x. If I divide by 3, I get 3x and 56x. 4x and 42x. I should have known that didn't divide by 5. 6x and 28x. This could take a while. 7x and 24x. 8x and 21x. Actually, if I remember right. Okay. So if I remember right, we are trying to get these to add to give me 13. Remember, we have to pick the one that adds to give us 13x. However, if I look at this negative 168, I notice that it's negative. So that being negative, that negative tells me I'm going to have one positive. And so if that's negative, I'm going to have one positive and one negative in all of my factor pairs. So So if I need them to add to give me a positive 13x, that tells me that the bigger sign, or the bigger number, I mean, is going to be the same sign as this. So the bigger number is going to be positive. So all these smaller numbers are going to be my negative. So I'm trying to get 13. And if I look, it looks like 8x and 21x give me 13. Okay, so here's how we do this. This GCF is like that annoying little brother. Do you have to have him? Yeah, mom is making you take him everywhere you go. Or sister or whatever. Dog, I don't know what it is. But something or somebody that your parents make you take places, it comes along with you. We keep the A. This 13 we split into the two that we chose over here that gave us 13. So instead of writing 13, we write the two things that added together to give us 13. Oh, and we keep the 28. So the A and the C that we multiplied stay. The thing in the middle, the B, becomes these two terms. Now what we're going to do is find numbers that I can divide both of these by. Okay, so if I look at 6 and 8, they can both be divided by 2, and they both have an x. Over here, if I look at 21 and negative 28, those can both be divided by 7. And so, again, we bring down our 5x. And then this is where it gets a little crazy. There's going to be a lot of parentheses here. So I'm going to have a big set of parentheses around all of this. So from these two terms, if I take out a 2x, what is left? So 6 divided by 2 leaves me with 3. X squared, remember when we're dividing by x, we subtract. So 2 minus 1 leaves me with an x. Negative 8 divided by 2 is negative 4. The x is out here, so I don't have any left for there. Then these ones, I've got a 7 in common. 21 divided by 7 is 3. I didn't divide by an x, so the x stays in there. Negative 28 divided by 7 is negative 4. And then remember that these two inside your parentheses, they have to match. Those two have to match. After we've done all that, we're actually ready for our final answer. Our final answer is our GCF that we took out at the very beginning, 5x. Like I said, just comes along for the whole problem. We don't do anything else with them. Then we write the stuff we took out. 2x plus 7. And then we write the stuff that matched, that was remaining, but we only write it one time. And that right there is our final answer. So if that looks familiar, that's cool because we actually did that back in Chapter 4 a lot, the AC method. So now let me show you factoring by grouping. And I saved this for after, and you'll see why. So my example here for factoring by grouping is 30x to the third plus 50x squared plus 48x plus 80. Okay, and again, first thing ever, and always is we look for a GCF. So looking at the numbers, you can see they're all even. So I can divide them all by 2, and I can't think of anything larger. And then also looking, do they each have an x? Nope, that 80 doesn't have an x, so I can't divide them all by 2x, just 2. So we take out that GCF of 2. We're going to divide everything by 2. So I'm going to get 15x to the third, 25x squared, 24x, and 40. Okay, now this is called factoring by grouping because I'm going to group these into two sets of 2. Now, does that kind of look familiar? Well, yeah, we did that same thing here, correct? So actually, 4 terms is just the end of 3 terms. So we're going to do the exact same thing. We're going to keep that 2 and make a big parenthesis, and we're going to look in here. 15 and 25 can both be divided by 5. And what's the smaller number of x's? X squared. That's what they can both be divided by. So 5x squared. 24 and 40 can both be divided by 2. Let's do this real quick. Okay, so 15 divided by 5 is 3. X to the third, x divided by x squared, I subtract. So 3 minus 2 is 1x. 25 divided by 5 is 5. And x squared divided by x squared is something divided by itself, which is 1, so we don't put anything there. Okay, now I'm going to take something out of there, and remember this has to match. So 24 has to somehow turn into 3, and 40 has to somehow turn into 5. So if I think about that, if I divide them both by 8, that'll make that happen. 24x divided by 8 gives me 3x, and 40 divided by 8 gives me 5. Then I write my final answer, bring down that GCF, the stuff that I took out from both, 5x squared and 8, and the stuff that was left that matched from both, 3x plus 5. Now, you might be asking yourself, hey, Mrs. Black, does it matter if I feel like writing the 3x plus 5 first and the 5x squared plus 8 second? No, that doesn't matter at all. It doesn't matter what order it's in because it's multiplication, and multiplication is commutative, meaning it doesn't matter if you put what you put first and second, they're going to get multiplied together. Okay, so if you have 4 terms, you'll factor by grouping, which as we can see is just the end of the AC method. If you have 3 terms, you'll factor by the AC method. So, Mrs. Black, what if I have 2 terms? Well, flip it over. Now we're going to see what happens if we have 2 terms. When we have 2 terms, there's 4 special cases. Difference of squares, sum of squares, difference of cubes, and sum of cubes. So we've got a lot of stuff, and try to get this covered in not a lot of time. So if these 2 first ones look familiar, that's awesome. We did those back in 4.4b, and I don't remember when sum of squares was, 4.8, 4.9, somewhere in there. So that should look familiar. So if you want to see, let's do an example of this real quick. Do example, if I have 9x squared minus 16, see here this is my original problem, and it fits the pattern something squared minus something else squared. I know that 9 is 3 squared, right? 3 times 3 gives me 9, so I put a 3 here. X squared, so they each get an x. Then my signs, I have 1 plus, 1 minus, and then for my L, 16 is what squared? Well, if you're not sure, you can always take your calculator and do the square root key, which is right here. Oh, you can't see that. You have to hit second and then this x squared, type in 16, and it gives us 4. So the square root of 16 is 4. Put it there and there. We're done. Now for sum of squares, oops, Mrs. Black had a typo. Sum of squares, everybody change this for me, please. Sum of squares should have a plus sign right there. So sum of squares is different from difference of squares. Difference of squares will have subtraction. Sum of squares will have addition. So please make that change for me. But it will look pretty dang similar when you're given a problem. So if I'm given this problem, oops, see the only difference is this sign. There's 2 terms. They're both squares, but this one has an addition sign in between it. So I still have 3x because that's the square root of 9x. I still have 1 plus and 1 minus. I still have 4, but now, because of that plus, these both have an I. And the reason is, if I take 4 times negative 4, I'll always end up with negative 16. But this needs to be a positive 16, so somehow I need to change that sign. without changing these two signs, because they are what makes me not have a middle term. So if I put the I on the end, remember I squared is -1, and that changes that up for me. Okay, so that's just a real quick review on those. Here are the new ones, sum and difference of cubes. So sum and difference of cubes, these are going to be different because they are cubed, not squared. So we haven't seen these before. But we will have to figure out where we'll do some cubing. It's like square root, but it's cube root. So if I have f to the third, in my pattern, I'm going to have f. Good grief. I did these wrong. I completely messed this up. Okay. These are the correct things, but I swapped them. So for the signs, we use SOAP, which I hope you all use every day, multiple times a day. So to use SOAP, you should have this sign should be the same as the problem. Okay, so it should be the same as the problem. So this is a plus, this one should be a plus. This is a minus, this one should be a minus. Then the next sign, so this was S, same as the problem. The next sign is O, opposite. Okay, it's going to be the opposite. So since that was plus, this one's going to be minus. Since that one was minus, this one's going to be plus. And then this last one is the A and the P. It's always positive. So I apologize so much for messing those problems up, but now we got to practice. Same, opposite, always positive. So we're going to have to memorize this for our test. So how do we get it? Well, it's f cubed, and the first one is just f, then L, then f squared, FL, L squared. So I try to remember it like this. F, L, then it's FF, FL, and LL. Of course, multiplying these things. So the first one is just the cube root, one after the other. Then in the second or longer set of the parentheses, we've got 2 in each. I'll show you what I mean. Let's just go ahead and do an example. This whole letter thing is a little confuzzling. Yes, I just made up a word. Deal with it. Okay, so our first example is going to be 500 x to the third minus 32. Now, how do I know if this is sum or difference of cubes? Well, the easiest way is to look at the variable. If the variable is cubed, then it's probably going to be sum or difference of cubes unless there's a GCF that I can take out. So let's look and see if there's a GCF. Those both can be divided by 2, but that would give me 250 and 16, which would still both be even. So it looks like my GCF is going to be 2 times 2, which is 4. So let's take out a GCF of 4 and see what that leaves us with. So 500 divided by 4 is 125. And 32 divided by 4 is 8. Okay, so what I'm going to do is I'm going to show you how to get the cube root of this. So we need to do the cube root of 125 x to the third. So grab your handy dandy calculator, and we are going to find the math button. It is below the green button. And when you press it, all this stuff comes up. So notice that this kind of looks like a square root sign, but it's got a little 3 in the armpit. That's technically called the index. So it's got a 3 in the index. So which one of these looks like a square root sign but has a 3 in the index? Number 4. So we're going to press number 4 and then hit 125, and it gives us 5. So the cube root of 125 is 5. The cube root of x to the third is just x. So that is going to be my f. So everywhere there was an f, I'm going to put that in. Same thing with 8. I'm going to cube root it. So grab your calculator, cube root of 8. It is 2. So everywhere there was an L, I am going to put a 2. So remember, you have to bring down your GCF, and then first I'm going to have a small set of parentheses, then I'm going to have a big set of parentheses. In the small set of parentheses, it's just 5x and 2. In the next set of parentheses, there's 2 of them. So 5x times 5x, then 5x times 2, and then 2 times 2. So in the second set of parentheses, there's 2 of each, 2 things for each term. But they get used 3 times, and then you switch to the next one because it's cubed. 3 of them, switch to the next one, 3 of them. Okay, to do our signs, we're going to use SOAP. Okay, so in my original problem, I have a minus. So it's going to be the same, S, opposite, so it was a minus, this one will be a plus, and then the last one is always positive. So same, opposite, always positive. Now, do you think we can let it lay like that? No, we're going to actually have to do that multiplication. So 4, this one doesn't have any multiplication to do. It's just 5x minus 2. But on the next set of parentheses, I do have some multiplication to do. So first I have 5x times 5x. So 5 times 5 gives me 25. X times x gives me x squared. Remember, opposite sign. Now in the middle, I have 5x times 2. Well, 5 times 2 is 10. And then at the end, I have, sign. Sign is always positive. And then I have 2 times 2, which is 4. And that is done. Now, some of you will not have to do this step. You can just go straight to here. And that's cool. If you can do that, more power to you. Okay, let's try another one. So on this one, I really